Just as usual, today's topic, today's part, which is the second part of our Polkadot smart contract campaign, is gonna be strictly about introduction to the Inc. smart contract. We're gonna be having a walkthrough of an Inc. smart contract. Pretty much, we're gonna be setting up an Inc. smart contract on our own and testing and deploying it. Just a very simple smart contract. So yeah, let's just get excited and let's get into it. Just as usual, if you have any questions, you can drop it in the chat or you can ask your question right away and I'll be giving responses to any questions that I get. So yeah. So without further ado, let's just get started. As I mentioned in the last call, we have Polkadot ecosystem allows you to build smart contracts. And there are currently three major ways to build smart contracts in the Polkadot ecosystem. Pretty much, there could be more than three, but right now there are three tools that are being used. There's the Inc. framework, which is Rust-based. It's a Rust DSL. And there's also the Ask framework, which is TypeScript and assembly script, pretty much because assembly script is a variation of TypeScript. And there's also the Solang, which is a Solidity-based smart contract library. So it compiles a Solidity smart contract into WebAssembly module. So the similarities between all these guys is that these three frameworks, they can compile down to WebAssembly module. So the summary is any language that can be compiled to WebAssembly module can be used to build a smart contract on the Polkadot ecosystem. But today, we're going to be focusing on the most popular one, which is the Inc. smart contract. We're going to be writing an Inc. smart contract, testing it, deploying it, and also interacting with it. We have a lot of time on that one. So the first thing that I want us to pay attention to is the fact that Inc., which is Inc., INK, and an apostrophe, it's kind of like written that way. Inc. is a Rust-based domain-specific language. So it's also Rust, but it contains some additional syntax and tooling that are tailored specifically for blockchain usage. So they have some special features. It has some superpowers that has been added to Inc. smart contract, to the Inc. language, to make it much more suitable for a blockchain environment. And the Inc. documentation that we're going to be following is available. I shared it in the last call. I'm going to share it again. Is the use.inc. One thing that I noticed is from the last call, the screen is actually pretty small. So you guys let me know if you can see the screen much better this time around. So I'm going to be zooming in a little bit more so that we can see what's going on this place. We're going to be using the this Inc. documentation as well as the pop-cli, which is a very important tool currently in the Polkadot ecosystem. I'm going to be zooming this in as well. So let me know if you guys can see this as well. So this is actually these are your go-to documentation for the Inc. Smart, for building an Inc. Smart contract, the POP documentation, as well as the Inc. documentation, the use Inc. documentation itself. So before we get started, there's some prerequisites that we need to have. If you're going to be following along, I'll actually advise that we follow along with this particular session. So if you have your laptop, you can also just follow along with these steps. It's going to be very explanatory and it's going to be very detailed so that anybody can get through. If you get stuck at any point, just let me know and I'll try and help you on that one if it doesn't take too much time. So the prerequisite that you need to make sure you have Rust installed because as I mentioned, Inc. is a Rust DSL. So it means you need to have Rust installed on your computer. You need to have Cargo installed. Cargo is like a package manager for Rust. So you need to have that installed as well. And you also need to have the pop-cli installed. It's very easy to install the pop-cli. You see the documentation here. If you're using a Mac OS, all you need to do is just run this command. First of all, it tells you to install Homebrew because you need to have Rust and all these guys installed. So if you have Rust installed and you have Cargo installed, then you can easily install pop-cli using the Cargo package manager that you've just installed. You need to run this cargo install force log, this command right here. Run this command and then let me paste that command right here. Pop. Yeah, and then you can also follow along on this documentation so you can see the command for installing pop. If you have Rust and Cargo installed, then it will be much easier for you to follow along with this particular one. Then once you have that installed, you have running on your terminal. I already have it installed, so I'm not going to install it. As you can see, once I click on it, then if you have it installed, it's going to show you the list of commands that you can run to be able to move along with this pop-cli. So I already have it installed, so I'm not going to be doing that anymore. And I'm also going to be going into the 1 second. I just need to, okay, let me, I don't want to be typing through this command. So I'm going to go into the folder where we're going to be working out of. I'm going to make a new directory, inc gsn demo. So the contract that we're going to be writing today is going to be a domain or a DSN, a DNS, or rather a DSN, a DNS, a domain naming service contract. It's going to be a very simple contract to be able to assign names to your wallet address, a very important feature in a blockchain ecosystem. So you don't have to be trying to remember, you don't have to try to remember your contract address every time. You can just use the name to, you can send that name to anybody and they can send you tokens in there. You can have something like dsn.eth or dot, and then anybody can send you tokens on that address. It's very easy to remember. You can even use any username that you want. So that's the kind of contract that we're going to be working on today. So before we get started, we're going to have to install and set up Inc. So one more thing that I actually left out of the requirement, the prerequisite, is you need to also have the substrate contracts node installed, which is a substrate node that has a pallet contract installed already. We mentioned on the last call that the pallet contract is the super glue frame pallet that allows a substrate blockchain to support smart contract development on top. So you can install any one of those nodes. But luckily for us, we're going to be using the pop-cli. So the pop-cli has a lot of SAS commands that allows you to set up a substrate contract node out of the box. So you don't have to set up the node by yourself and all of that. It's much easier to work with. So we're just going to go ahead into the smart contracts part of this documentation. So the first thing we're going to be doing is to create a new contract. The first thing we're going to be doing is to create a new contract. And since we're using pop-cli, Pop has a command that allows us to set up a new contract using pop new contract. If you run this command, it's going to give you a list of guide that you can follow. It asks for the name of the contract. You can put inc DNS, which is the name of the contract that we're going to be building this time around. Click on that. And then where should your project be created? I want it to be created right in this directory where I'm in. So I'm going to select that. And a cool thing about this is it gives us different templates. So we have a contract example for Inc, which is the most basic contract. Usually is a flipper contract, is the most basic template for a smart contract in Inc. And you can also use an ERC-based smart contract in Inc, which is going to set up a smart contract that already has the PSP standards initiated already using POP. We're going to be going with the most basic approach, which is the bare bone approach for smart contracts, the examples. Once you click on that, select the contract, the standard flipper contract, and then we already have this installed. If you check, we see we have the Inc DNS already installed. So one thing I'm going to do next is to open that folder right here on my VS Code. You can see how pop-cli makes this whole approach very easy. Inc DNS. Now we have our basic structure for an Inc smart contract, which involves a cargo.toml file, a git ignore file is very necessary, so you can choose the directories and files that you want to push to your GitHub repository. And then we have the main entry point, which is the lib.rs. This single file contains the smart contract that you can deploy. You can do anything that you want to do with this smart contract. And then this is the most basic approach for building a smart contract. Although there's also one more approach that we're not going to use right here, which involves using the cargo contract, since you can pretty much the Inc framework itself is technically a crate as well. So you can install it using cargo. If you check this repository right here, you see creating an Inc project, you can just use cargo contract. If you install the cargo contract crate from crates.io, then you can also set up a new contract using that approach, cargo contract new, and it gives you a similar project structure to what we have here. You can see that it also added some two new files, a folder, a target folder, and a cargo log. The cargo log itself is just related to the cargo.toml. So whatever dependencies you have, everything is kind of like sorted onto the cargo log. If you're very familiar with Rust project, you know what the cargo.log file does. And then this target is going to contain our deployment. So when you deploy your smart contract, it's going to be stored inside this target folder. So currently we haven't deployed, so it just contains some basic things that we don't really care about so much for now. So we're going to be going into the lib.rs, which is what exactly is the file that we care about most of all. The first line, if you pay attention to this, is this single line that we have right here. I'm gonna increase this. Proc macro create is missing. This is kind of coming from the Rust analyzer file. One thing that let's go. This is coming from Rust analyzer, so it doesn't really matter. It's going to clear away very soon. But the first thing that we need to care about is this single line at the top here that says CFG attribute. The whole purpose of this file, it tells the compiler to disable some STD features, some standard Rust-based features. So you can see this particular line of code right here. It says, if not feature STD, telling you like if the standard feature is not enabled, then disable the no STD, the standard Rust-based libraries. And also don't expect us to have a main.rs file, which is because this is a library, so we expect to have a lib.rs. It's just standards that you need to have at the beginning of your Rust crate so that you can remove a lot of the heavy Rust standard features that are not really necessary for the blockchain ecosystem. We don't want to have very large data structures like vectors and all of that, or strings. If you want to use them, we want you to be able to actually bring them on purpose. So we want this to be as deterministic as possible so we know how large whatever we are deploying is. Another thing that we notice is this ink contract here, which it says this ink contract is a macro that is coming from the ink environment itself. So these are part of the superpowers that the ink Rust-based DSL actually gives us. By defining our module using this ink contract, it tells us that whatever comes after this is going to be a smart contract, an ink-based smart contract. So that's exactly what this is talking about. And a simple walkthrough for what we have on the bare bone of this one, you can see a bunch of all these macros right here. There's also the ink storage macro, which allows us to define the storage of our smart contract. Just as easy as that. This shows that this basic smart contract that we have is going to be storing a single value, which is a Boolean. And then we also have some implement statements right here. We have the ink constructor, which allows us to initialize the smart contract. We also have some messages, which are the transactions that you can do on this smart contract, and the unit test as well. We're going to be going into each of these ones. It's not going to take a long time. We're going to be doing these by ourselves very soon. Just need to make sure we're following along. Awesome. So one thing, we need to remove this error because it says it could not find scale info in dependencies. So this scale info is actually needed so that these macros can be understood by some of the extensions that I have on my computer. So I'm just gonna bring it in. The scale info. It's also a crate from crates.io that we're gonna be using as well. So yeah, now that error is gone. So the first thing that we want to do whenever you want to start an ink smart contract, you need to already have an idea what you're going to be storing in your ink smart contract, right? Because at the end of the day, the smart contract itself, what it's supposed to do is to store some values on the blockchain and give you some functionalities to be able to update and manipulate those values that are going to store on your blockchain. So since this is a domain name service, naturally what we want to be able to store are things like a mapping of the name to an address. We want to have that. I'm going to take this out. So I'm going to delete this. Once I delete this, we're going to see a lot of errors because the current smart contract is actually dependent on that. And this is one reason why it's very, very cool to use Rust, because it's, first of all, it makes sure that you're not going to make all these kind of basic mistakes when you're building your smart contract, because it is strictly typed. And if you try to pass a value that's not going to work, Rust is already going to warn you. And it's never going to allow this kind of code to compile. No matter how much you try it, you won't be able to compile this kind of code. So what we want to do is we want to update this. So the first thing that we want to have is a storage name to address. And what this does is a mapping. So I'm going to explain what a mapping is very soon. It takes an hash and an account ID. Just in case you're wondering, so a mapping is equivalent of an object. If you're very familiar with what an object is, it has a key value pair, and a mapping is actually specific to an ink environment. So you can see we're bringing it out from this ink storage mapping environment, which is actually coming from this ink dependency that we have in our cargo.toml. And good thing is you can read about this crate if you go onto crates.io. All these crates are actually available on crates.io right here. This is the ink crates right here. You can see all the things that it contains. If you open these crates right here, this is how to add it, cargo add ink. And you can go into as much information as you want by reading through this guide. This particular crate is what is responsible for allowing us to build ink smart contracts. The repository is also open source, so you can take a look at it at your free time and contribute to it. So that is what allows us to bring up this mapping. It is actually specific to ink, just like I mentioned earlier. So it gives us a key value pairing. So the key right here is going to be a hash, and the value is going to be an account ID. An account ID is also very specific to the ink environment, and it's a way of representing addresses. It allows us to represent addresses on an ink smart contract. So now we know that this storage right here, it expects a key of the user's name and a value of the account of the address. We also want to have a name to the owner. So also a mapping of a hash to also an account ID as well. So, I mean, I'm putting these two things because if you're familiar with domain name services, you might be the owner of a domain name. So you actually own this particular name, but you've not assigned it to any particular address. You just bought it for yourself. So this particular, so let me just arrange it in the right order that it should actually come. So the name to address now shows us the name and whoever is currently using that address. At any point in time, you might want to transfer that address to someone else. Maybe you are borrowing it to someone or that kind of thing. So you remain the owner, but the address belongs to someone else. So this is how you can define a storage in an ink smart contract. Very easy, no stress at all. And now we're going to go into the next part of this. Now that we have the storage, we need to think about how we want to initialize the smart contract. One key thing that you'll notice in an ink smart contract is it has multiple constructors. It can have this constructor right here, this macro. It is what enables us to initialize our smart contract. An ink smart contract can have as many constructors as you want. What that means is you can initialize your smart contract in any way that you want, as long as it's initializing this particular struct right here. So in this one, we're going to be having two constructor functions. The first one is going to be let's say the most popular one that we're going to be using most of all, actually. A very common use case is to have one that just initializes everything as default. So we're going to take this guy out because we don't want to pass any arguments. If you want, you can also pass an argument. So just in case you want to pass a list of owners already before you initialize your smart contract, you can have another constructor that takes an argument. You can have one that doesn't take an argument. And ink is going to know which one you're trying to call. It's never going to get confused on which one you're trying to call. So let's have a mutable function right here for the name to owner, which is expected to take a mapping of new. And then what this is going to contain is going to just be name to owner dot insert. You can read more about this hash function, about this mapping function. We don't need this because the hash is actually native. So one thing that I was going to talk about is if you want to know more about this ink mapping storage, there's a very good documentation right here about the basics and the mapping, storing values. Yeah, this is the mapping function right here. You can read more about it right here. And then you can also take a look at how to work with the mapping in this particular documentation here. It shows us a lot about how to work with the mapping, how to work with the mapping data type in an Ink smart contract. So you can see mapping.default, it sets up like a default mapping with no value in it, which is what we just, which is kind of similar to what we just did right here, mapping.new. And then we insert the key value. One thing that we also want to have before we move on is we want to be able to create like the zero address. Zero address is pretty much just an address that it's an address, but it's not a useful address because it's a zero address. If you send money in there, it's pretty much useful for burning the money because it has a known private key and it's not something that you can actually use to receive money or that kind of thing. So it's very useful for representing zero addresses just like that, addresses that are not going to be assigned to any user. And you can see how I define it right here, account id.from. It pretty much just takes a vector. You can see it takes a vector of zeros, all zeros. So that this is kind of like how you can define a zero address. And we're going to assign this to hash the default, and then this is going to be zero address, and it's expected to take a reference. So we're just going to pass a reference right here. This is the first one, and we just need to return the struct because that is what is expected. It's expected to return a self, which is this ink DNS, and sorry, this is hash. No one is failing. So we're just going to return this name to owner, and then the second one as well. The second value, let mute name to address, mapping.new, and then name to address dot insert. We insert the right value in here, hash the default, and then we also assign it to the zero address. Yep. Okay. So the next thing that I want to do is complete the initialization of the smart contract. Now we have this our smart contract fully initialized. If I save this, okay, so now we have the constructors working. We have two constructors, the new constructor and the default constructor. It doesn't matter which one you use, it's going to initialize the smart contract. And one thing you can also see is the fact that this constructor right here, the default, is actually referencing the new constructor. Rust also, the Ink smart contract also works that way. You can refer to another constructor from within one of the constructors, and it's just going to initialize the contract based on that. So this one might be useful in case you want to set up some additional logic. And just like I said, you can have as many constructors as you want. We're going to remove these extrinsic functions. But before I remove them, I want us to pay attention to this macro right here, which is the Ink message macro. This macro is what is responsible for allowing us to send a transaction to the Ink smart contract. If you want to send a transaction, you can use this Ink message, and it allows us to define any transactions that we want to define. So the first transaction that we're going to define is a simple register transaction. All it wants to do is maybe you want to register a new name. Register. Let's take out the function that it takes. If you want to register a new name, I mean, obviously you're going to want to pass the name that you want to register. It's going to be a hash because the name is expected to be a hash right here. And you might also want to pass the address. So let's call it to, which is the address that you want to register it to, account ID. Okay. One thing that's also very useful is because Rust is statically, you have to pass the expected type that you're expecting from this particular thing. So we're going to use the result enum, but the result enum that we're going to use is slightly different from the plan one that we used to. We're going to define it up here, and it's going to be type result equals to, sorry, it's going to be a generic, and it's going to take result, and then the generic type that will pass. and then one order. It takes two dynamic types, two generic types. So this one and then this error that we are yet to define. So you know what? Let's just go ahead and define that error right now. So the error is an enum, and it's very useful for specifying the types of error messages that you're expecting from this your particular smart contract. One of them that we're going to use is name, or let's say just in case you're trying to register your name and it's already registered. So this is one of them that we can use. Also, I'm going to put in some superpowers on this enum right here, and I'm going to explain what they are. All these are actually in the Inc. smart contract documentation. If you go into the error, 1 second, let's take a look at errors. Let's just search for errors right here. No, not here. Sorry. Okay, let's see. We're gonna be looking for the error basics. We need value some storage. Just 1 second, because all these things are actually specified in this particular documentation right here. Just needs to contract template. Sorry. Okay. Chain environment types. Not here. Not here. Examples. Smart contract examples. Now this is not where I want to come to. Custom data structures. Just trying to look for defining the errors right here. Can take a little bit of getting used to this documentation, but you have to, once you find it, the best idea is to just bookmark them, have it bookmarked, but just trying to find the errors right here. You know what? It's going to take a little bit of time, but just for the sake of it, this allows us to, let me just explain what this is doing. So this is, if you're very familiar with Rust, this is just the basic Rust derived macro. It allows us to be able to debug this error message so that we can print it out if you need to print it like a print line statement in your terminal or somewhere. That is what this debug is useful for. And then the partial equal and the equal traits, these are traits. So these two traits, they allow you to compare two different errors to make sure that they are the same or not. And also, we also have three other traits, which is the encode decode, which allows us to encode this error into Inc. compatible types. So we can encode them or decode them. The type info as well just gives us typing on the error so that whenever you're reading from an ABI or from a JSON file, you'll be able to know exactly what each of them represents. That's pretty much what this is just talking about. Nothing complicated is happening right there. So right now it's throwing an error because it expects us to pass an OK statement just in case it's working. So if you save this, you see there's no error anymore. So now the first thing that we want to do, we want to make sure that whoever is okay, you know what? Let me just remove this to one here. So we're trying to make sure that whoever is calling this function is going to be the one that owns this name. So the first thing that we want to do is to get this caller, and we can get this from the self.end.caller. So because we've initialized this with these macros, it gives us some extra features like this env function, this env method that exposes the caller of the contract. And this is how you can refer to the person that called this function. By doing self.m.caller, you can refer to the person that called this function. And then the next thing that we want to do, we need to make sure that this person that's calling this function with this name, we need to make sure this name is not already registered. So how we do that, we can use a normal if statement to check that this is not registered. So if self.name.toOwner.contains, sorry, .get. So we need to just check if this actually exists. We need to check if this name.owner.get exists. So if it exists, so that means the user is already registered, and then we want to return the error and say, oh, user is already registered. And that's what we do right here. We just return an error saying name is already registered. This is simply how you can return an error from your Inc. smart contract. Now, if you save this, you notice how there's an error here. Mismatched types. Okay. We need to check because this actually returns an option. So this get function, it returns an option in Rust. An option, if you guys are familiar with Rust, an option just takes a generic function and it returns two things. Either it returns sum or it returns none. It returns sum with the value that is expected. You can return sum with the value that is expected, or you can just return an error. So maybe some color like this. So what we need to do is handle this function very well because it doesn't return a Boolean, right? And this if statement is expected to take a Boolean. So we need to check if this is sum. So which means if getting this returns a value, then just throw an error saying this already exists. So if you save this now, you shouldn't get that error anymore. And then the next thing that we want to do, since we can confirm that this is actually not registered, then the next thing we want to do is we can just save it to the self name.owner. So we can assign this name to the caller as the owner. And that is just it. This actually completes this function, right? Easy one. So one thing that is also very necessary in an Inc. smart contract is events, pretty much in any contract, because events allow us to be able to keep track of what is happening in the smart contract. And also one key thing that events do for us is that we don't have to store all the owners of the smart contract of this name, because as you can see, it only takes the owner at this particular time. So if the owner should change, it's not going to store the owner that was the previous owner, it's only going to store the current owner. And the way we can know all the owners of a particular name in this scenario is to listen for the events. So we can index the events off chain, and then you can create your own database, or you can create your own data out of that. So we're going to define some events right here. Also, defining events, it also has Inc. also exposes some macros that we can use to define an event. So for this event, we're just going to call it the register event, which is like this. I have this magic on my VS Code, so it just auto completes this. But if it's not what we need, because what we need here is register to, we want to call this to, and then you can see something extra here, which is the Inc. topic. So the topic is needed because when you are indexing your events, it's kind of like something that you can filter the events by. So you can look through this event and look for all events that have a particular name because it has this topic. So it's just the topic is let's say the main thing that let's call it the main thing that you are emitting from your events. So if an event has a topic, and it's always advised to have at least one or two topics, the topic should be the main things that you want people to listen for when they are indexing this event. So in this case, whenever you emit this event, we want people to be able to search this event by the name or by the address of the owner of the name. Sorry. So the next thing that we want to do is to actually emit the event. We want to actually emit the event. And just like I said, this self environment it also gives us access to be able to emit the event. If you see this env as well, you can still do it the same way. Emit event. This is the function to emit the event, and then register, which is the name of the struct that we're trying to emit. And then we can give it the name, and the tool can be the caller. Just like that, we already completed this function. We already completed this first function. Moving on to the next one. Does anybody have any question if I move on to the next one? Because it's just going to be very similar to what we've already done right here.
Yeah, so if you have questions, please, you can start asking. Just unmute your mics and just ask away.
Okay. Really good. The next function that we want to do, I'm just going to copy it because so that we don't take too much time of ourselves. So I'm just going to copy the next function from here because I already I wrote it down just to make sure that everything is working fine and test it. So I'm just going to put this one here. This function allows us to update an address. And as you can see, a bunch of these things are not defined, and we're just going to define them right now. So the first one that we're going to define is a way to get the owner. As you can see, initially, I just wrote it in here. This is the simple function to get the owner. But now I'm going to have to extract this logic out. Let's just extract that logic out, and we're just going to call it another message so that anybody outside the contract can also read and just get whoever the owner is. It's going to return an option. So it's either it exists or it doesn't exist. That's just what the get owner is all about. So if you can see right here, we have the set.get owner. I'm going to change this back to get owner and the name. So yeah, I'm going to minimize this register function because it's already working. One more thing that we also see here. So if you're trying to update an address, that means you've bought the name, but now you want to assign that name to a particular address, that it is your own wallet. You want to assign it to a particular wallet address. Then you might want to need this update address function, which is a very simple function. What it does is it gets the caller of this function, and then it also tries to get the owner of the function. Like I mentioned, the owner is an option enum. It returns an option enum right here. And we can match this enum to check for each hand of this enum. The two things that is expected is either it returns none, that means nobody exists, or it returns some with the value of with the address of the name. And that is what we're doing right here. The first match hand, it checks if it is none. That means we don't expect the name to be none. If you want to update the address, that means you are very sure that the name exists. So what I'm going to do is add this error into our error enum right here. And you guys should follow very closely right here. We add this enum into our error enums, and this is just going to define a list of all the errors that are possible on this smart contract, just like I mentioned earlier. We also have another one that checks that the caller is the owner, and we're going to add that one here as well. Caller is not owner. Save this, and then this line should disappear. So one thing that we want to get is the old address, because once you update it, you need to get the old address first of all, because once you update it, then you're going to get an error. And before you return an OK statement, to prevent things like reentrancy, we try to update the state first of all. So we've updated the state, and then that is only after then that we can now emit the event, the necessary event. And that is only after then that we can proceed and return this one. And the reason why we have to do it this way is because a smart contract, if you don't update this thing, somebody else, if you don't update this and then you can next call, luckily for us, we're not making an external call on this place. But if you try to make an external call to another smart contract, if that smart contract is very vulnerable and it's malicious, it can recall your functions and then start repeating the same thing over and over without finally updating the state. And that is something that we don't want. That is what we call reentrancy, which has cost smart contracts a whole lot of money, and we don't want to lose a lot of money. I mean, we don't want to lose money at all. So that is why we update the state before we do anything else. And then we need to also update this new event. So whenever you update an address, it's actually very advisable to emit events for pretty much anything that you do, as long as it's a function that tries to update the state of your smart contract. And you'll notice something between these two functions that I've defined. If you check this one, these two functions, one of them takes a mutable self, and one of them just takes a reference to the self. And this is so because this function right here is only querying the blockchain. So we are not trying to mutate the state of the smart contract. But for this guy right here, we're going to be needing to mutate the state of the smart contract, and that is why it takes a mutable reference to the smart contract itself. So we need to pay attention to that. And this is how the Ink smart contract, or anywhere you're calling it, this is how they know if it's a function that can mutate the contract or if it's a function that's just querying the state of the contract. Once you see that it has this mutable self, then it's expected to mutate the smart contract. So one next thing that I'm going to do is also add the updated address event. Have it right here as well, just to save us a bunch of time. I'm just gonna copy and paste it. So you can see it also has some topics. I'm gonna show you something about these topics, because even though it's advisable to have topics, there's also a limit to how many topics you should have in your events. honestly, even this event, there's also a limit to how many things you should be emitting. You shouldn't just be putting like 20 things inside this event saying you want to emit them. It's only logical to emit the important parameters that are going to be needed to tell us all the information about what just happened in this smart contract. Sorry, I need to drink some water. Yeah. Ooh, this is make your voice crack, so you might need some water at this point. And if you guys have water too, this is a time to drink some water because we're going to be getting slightly deeper into these things. To be honest, writing the smart contract itself, I would say, as long as you know what your smart contract is supposed to do, it's actually the easiest part of this. It's the most fun part of this. The challenging part might come when you're trying to test the smart contract and all of that, because that is where you need to get the types correct. You need to know what exactly you're passing and all of that. But writing the smart contract itself is not so much of a problem. Currently, we've written two functions already and they're working very well. The next one that we're trying to write is a way to transfer ownership of the contract to someone else. So if you want to transfer ownership of this, your name, sorry, not the contract, of this, your registered name to someone else, you can do so using this transfer function, right? As you can see, it feels very similar to the update address function. Let me minimize this one. So we have full focus on this guy right here. What it does as well, it gets the caller, gets the owner, and makes sure that the name is registered. If it's not registered, there's an error. So that whoever is calling this smart contract, owner, which is owner in this section, get the old owner, insert the new, you start that into the name. So, and then we also emit a transfer event. So this is one thing that we need to redefine, this transfer event. Let's get this involved right here. Let me get this. Let me get this right here. Yep. So we have pretty much the same syntax. The transfer, it has the topic for the name, topic the old owner, and then a link for whoever is sending it. I mean, whoever is the one that's transferring the name to someone else. Pretty much these two guys should be the same people, but for the sake of, for the benefit of that, let's just make them different guys. So we have this, and then the last function, this is also working. The last function is also going to be similar to the transfer function, but it's going to have a little bit of tweak because, so if you transfer the name to someone, it doesn't guarantee that the address has changed, right? All that gets transferred is just the owner of the name. But the person that's currently using the domain name might actually be another address, and that's something that we don't want. So I created a new function that also takes a third parameter, which is the new address. And what this guy does is once it transfers, it also updates the new address to the new one that we sent. And consequently, it's emitting two events, the transfer event and the updated address event. Very cool. I mean, we're very smart for doing it this way. So we don't have to, because it costs gas fees to make this function, to make these transfers, to make these transactions. You have to pay gas fees. So imagine doing this transfer and then you have to still call another function again to update the address. That means you're paying gas fee twice, but we can just pay that gas fee once. And one cool thing, this is just by the way, actually, if you are the one that developed the substrate contract node that you are deploying this smart contract on, you can make the smart contract cost free for everybody. So nobody's paying gas fee. You just have a giveaway smart contract where anybody can just call it for free. They can use it for free. But I mean, you can always make your money in any other way because you determine how the logic of your smart contract works because you are the one that deployed the blockchain. So this is a very unique thing that a lot of blockchains don't really have. But in the most cases, you want to deploy this smart contract on an existing parachain that already has a substrate pallet contract implemented. So this covers this for the transfer and update address. One last thing that we want to do is just a function to get the address. It's going to be very similar to the get owner function. Very, very similar to the get owner function. And this is just what it looks like. It just reads the mapping and then just gives us the value. So right now we're done with this. We're done with this guy. I'm going to remove the end-to-end test because we're not going to cover end-to-end test in this function, unfortunately, because of time. But I mean, end-to-end test, honestly, it's very valuable to do end-to-end tests, but one thing I'm just gonna one expo that I used to give is when I used to do like a lot of smart hackathons and it used to involve ink smart contracts, I usually wouldn't include the end-to-end test. And my reasoning behind this is as long as the unit test works, I'm always going to deploy this smart contract somewhere, maybe from the front end or from the software contracts UI, whatever end-to-end test that I need to do, I'm going to be doing it from that front end or from this contracts UI. But the end-to-end test is very useful if you're working from a team. Say you are like 2 or 3 people, you guys are working together. You want to make sure that somebody does not just suddenly change the logic of the smart contracts. But one more thing, one catch with that is if you do your unit test very well, if somebody changes the logic of your smart contract, the unit test is going to reflect that because it's going to start failing and then you have to update that unit test. So the end-to-end test is very valuable, but if you are pressed for time, make sure you do the integration from the front end or from a substrate contracts UI, which is even a much more visual approach to the end-to-end test. So this is the unit testing. Before I go into this, I'd like to actually try and build this smart contract. So just like I said, we're going to be using the pop-cli. So pop-cli exposes a lot of primitives that we can use to interact with our smart contracts actually. So we're going to be let me go into the documentation for it. So we've created the smart contract. It's working. We have the basic structure. We have all these. Next thing we want to do is to build this smart contract, right? So if you go through here to build your Ink smart contract, make sure you are inside your Ink contract directory and run the following command, pop build. So if you run this pop build command, I assume it's going to fail because it's going to give you more information. So because this pop-cli is actually a tool that is useful for building parachains and for building smart contracts. So we need to specify whichever one we want to build. So in this situation, what we want to build is our parachain, our contract. So we just do pop build contract and then we run this and then hopefully it should work. I mean, we've done a lot of job. We don't want this thing to just show us a lot of red. It's going to take a while for it to build the first time because it's going to try and go through your dependencies and all of that. So it's going to run through all of that. It might take a few seconds for it to build. But let's just be patient and wait for it. And this is a good time to take any questions. If you have any questions based on what we've done so far, anything that looks confusing or anything that looks complicated, I'm going to be taking questions right here.
Yeah, so if you have questions, please just unmute and ask away, please. You can start asking your questions. Thank you.
So yeah, this fails. Fortunately for us, it fails. And this is somebody asking a question.
Yes, I have a question.
Okay.
Can you hear me? Clearly?
Yeah, definitely. I can hear you.
Okay, so when you did pop like new contracts, I think maybe I missed a step. When you did pop new contracts, right? Before I knew it, when I looked at your code editor, I could see this target folder.
Mm-hmm.
Right, but in mine, I don't think it's there until I don't think I could see it until I built the contracts.
Yes.
Is something wrong?
That's a good question, actually. Yeah, that's a very good observation, actually. A very good observation. It shows that you're following along. If you're actually following along as well, you will notice that you wouldn't be able to see this target folder or this cargo log folder until you actually do the pop build. And that is expected to be. The reason why this actually came up in my own terminal is because I'm using this Rust analyzer, right? And the work of this Rust analyzer is it tries to run through my code base and check if there's anything happening. And that's part of the reasons why I'm getting a lot of linting error and so on. So initially, when I ran this code, the Rust analyzer started loading, and then it did a little bit of cargo check. Similar, it's not the same thing as pop build, but it's kind of like cargo check. It checks the code base to see that everything is correct, and that is what actually gave out to this target folder right here and the cargo.log right here. Does that make sense? So because I have this Rust analyzer installed, If I disable this, then it wouldn't show me this target until I actually did pop build. Does that make sense?
Yeah, that makes sense.
Yeah. So this is failing, and the reason why it's failing is something that I mentioned earlier, because if you can see, it says maximum of 4 topics exceeded. So in your Ink smart contract, you can't have more than 3 topics in a single event. So if I remove this and then I try to do pop build contract again, it's going to be much faster this time around. It won't take as long as earlier. So let's just wait for this. Yeah, now you can see it's actually generating. It says original WASM size. It gives us the size of the WebAssembly module that generated. And it also gives us 3 particular files that you can find in the Ink target right here. This is Ink DNS contract. This is, I wouldn't call it gibberish, but most you wouldn't understand what this is talking about. But it's very similar to an ABI. This also, the WASM, this one is not even display. You can't display this on the code editor. If I say open anyway, it's just going to display a bunch of gibberish that nobody will be able to read through. And then it also displays a JSON, which is very similar to an ABI. If you're familiar with EVM smart contract, this looks just like an ABI. So these are the 3 things that you actually get from building your smart contract. And we're going to be using these 3 things. I'm going to explain what they are. This is an ABI. This is a WebAssembly module, the WASM file that is outputted from building your smart contract. And this is what you can use to deploy your smart contract on the smart contract UI, which we're still going to do towards the end of this call. So the next thing that we want to do, since that's the only question that we're going to get for now. So the next thing we want to do is actually test this smart contract. And this is where we actually might get a little bit of an issue, because testing the smart contract is actually, like I said, is slightly much more complicated than writing the smart contract, which is, I would say, is actually expected to be like that, because testing is kind of like a strenuous thing. So the first thing that we want to test is we want to test that the register function works. This works just like an So this is the main difference between testing an Ink smart contract and testing a normal Rust function. If you're testing a normal Rust function, all you need to do is just use this test macro. But for Ink smart contracts, you need to put in this Ink test. And this just gives you some extra features, like adding some extra assert features and assertion features and some of that into this function that we're going to define next. So the function is going to check that the register works. It's going to check that the register works. And then the first thing that we want to do is initialize the smart contract, which is the normal thing that you would want to do. Let's call it, let's mute Ink DNS. Ink DNS equals to Ink DNS.new. It doesn't take any parameter, so we don't have to worry too much about that. So this actually gives us a reference to the smart contract that we have defined above. And the next thing we want to do is to get a list of accounts. So now you might be wondering, how do we get addresses? How do we get some of these things? So that is where this Ink environment actually comes in. From this Ink, you can get a list of functions that you can use to test your smart contract. And we're just going to bring in one of them right here. One of them is the default account. I'm going to define it because we're going to be using it very often. I'm just going to define this function right here. Default is going to return a list of accounts for us that we can use. Let me bring it here. And funny enough, you can see documentation for this thing if you go to the Ink crate, just like I did right here. If you come here, ink.m Rust. If you come here and then you start looking through this particular crate contains a definition for all these guys, default contract and all of that. 1 second. Think from the environment. Not here. Used to host. All these definitions can be found by playing around. You go through this craze.io right here and you find a large number of all these guys on here. The default account, sorry. Let me see. Sorry, this actually goes through everything. What I want to do, call it from here. 1 second. These functions are actually defined here. You can see the account ID, a large number of all these, on code hash, return value. All these things are things that you can use to actually interact with the smart contract. But I'm trying to show you the env on, I think it's maybe inside the end-to-end. It should be, yeah, Alice, Bob, and all these guys. You can see a way to refer to them. This is actually used for end-to-end for testing. This is not the one that I actually want to show you. But if you go through this env, we don't have like all the time. But if you go through here, you'll be able to see like the default accounts, how to access them from this environment. Everything is defined in this documentation right here. So it's taking a little bit of time. But so yeah. Environment. So this actually going to return a list of accounts for you that you can use to test your function. Let's get access to one of them. Let's call it Alice, and then we're going to say default account dot. You can see it has. Oh shit. Sorry. Let me put the right typing on here so that we can have the typed inference. So yeah, this is actually something that I wrote in the function that I'm using right here. And then if you check this out now, you can see a bunch of list names, Alice, Bob, Charlie, and all of that. If you go here, if you go into the test API, which is cargo registry, by clicking on it, test API, this is actually one of the crates that we've installed from cargo.terminal. You can see how the default accounts are defined right here. If you also try to open it from here, it also shows all the default accounts that you can use. This is coming straight out of this, env crate, this env 5.0 crate. So if you take a very deep look at this crate on crates.io, you get familiar a lot more with how to test all these functions. So we're going to be using Alice key pair for our account ID. You see, it gives us an account ID now. And then we also need to define a name, which is a hash. So the name, you can just say hash.from. This from function, it expects you to pass in, it expects you to pass in a vec or anything. So we're going to pass in a vec of 0x20, anything. And then we're going to tell it to have a length of 32. So this is all things that are pretty much just basic, pretty much just Rust language. This is just Rust, nothing out or outside of Rust that we're doing right now. And then what we want to do is we want to check that the register that the register function works. But before we do that, we need to also be able to tell who is actually calling this smart contract. And that can be done by using also the env.test as well. We're going to be using that one too as well. If you take a look at this, so the same function, set caller, if you take a look at it, it sets a caller for the next call. So this is actually a way to mock who is going to be calling the function. If you take a deeper look at this crate that we went to, you can even see a function like advanced block. It allows you to advance the chain by a single block. You can call this multiple times to advance the block by like 10 blocks. That means you need to call it like 10 times or something. So these are actually utility functions that you can use to test. Set callee, that's the contract that you're calling. Set contract. All these things are functions that are exposed by the env test, by the env crate, this crate right here. Those are all exposed by this env crate right here. So if you actually take if you take time to go through this particular crate, you learn a whole lot of things about how to test smart contracts on Ink. So the next thing that we want to do is actually update the caller. We are going to make Alice the caller so that Alice will be the one that owns the name that we're going to be using. So the next thing we want to do is now write some assertions. Assert equal. So we want to assert that whenever you call this register function, it should actually return an OK statement. This is an assertion that you can do, a possible assertion that you can do. And if you've actually called, because this is expected to mutate the state, so you don't need to even wait for the response. You can just go ahead and do the next one. Check the owner of the smart contract. Because when you call the register, the expected thing is that it's supposed to modify the smart contract owner. So you just need to verify that it actually does that, and then some Alice. And then one more thing, if you also try, you can also try and call this function again. So try and assert that calling again fails. So you can say, try and call the function again without updating the caller, right? So we are not updating the caller, we're trying to call the function again. We expect it to fail. So let's save that and then try and run test. Let's try and run the test on this guy. Pop test. Also, if you go through the pop command right here, so now that you've built you have to make sure that you build before you can test actually, otherwise it's not going to work. So now that you've built it and you're sure that it's building, you can now do the pop test contract function, which is also another CLI command that is exposed by the pop CLI. So pop test contract, run that and wait for it to actually run whatever we're trying to do and see that the test actually passes. While this one is running, if you also have any other questions, I mean, this would be a good time to shoot ahead with the questions. I'm not taking any more questions.
All right, so please ask your questions. So don't be shy. Oladokun, Femi, Ifedimeji, you guys can start asking your questions.
I mean, it's always good if there is no question. It shows that whoever is talking is doing a very good job of making these things clear and nothing is confusing. So,
in short, you are doing well.
yeah, exactly. So this is going to take a while because it's going to try and build again for the test and then try to pass the test. But let's just wait for the test to make sure that the test is going to pass. Okay, 776. Once it gets to 776, it's going to be done. So yeah, thankfully our tests are passing. We don't have any failed tests, which is very good. So one more thing that we can do, we want to check the transferring the ownership of the address works. So the reason why I'm picking transfer, because there's a lot of things that we can test, but we are actually running out of time. I can feel like, so we're running out of time. So we're just going to go ahead and test this transfer. And I'm choosing this one because it encompasses a lot of things. Before you can transfer, you need to be able to make sure that the register works. And also you need to also make sure that the updating of the address works. So let's just go ahead and do that. So right now, what you can see, it's pretty similar to what we did before, register. Then one thing that's just different is this recorded events. So this is actually a way to be able to test the events that have been emitted in your smart contract. So this is inkdns.new. This is a way to test the events that have been emitted in your smart contract. And it's actually coming from this inkenv test. So this guy is our guy actually, this inkenv. So he's the one responsible for doing everything that we try to do in this ecosystem. One thing that you can do so that you don't have to type, because this thing is actually like a lot of things to type, you can just import it once. You can import it using the use command, and then all you need to do is just write test everywhere you want to do it. So you can just do it this way so that we don't have to be writing the same thing over and over. And this works. So this one is actually just testing that sorry, this is ink, not in. It's actually just testing the amount of events that have been emitted. So when you do the register, we expect only one event to be emitted. By the end of this transfer function, we expect one more event to be emitted. So that makes it 2 events emitted. You can also test to see the actual event, the actual data that has been emitted in the smart contract, but that would involve decoding these events, these emitted events. You need to decode it and then try and do that. So if you run pop test contract again, should be able to see that it passes as well. So yeah, thankfully it passes, which is very good. So you can see how to test the Ink smart contract. It's not a problem at all. You can just test the Ink smart contract. The last thing that we want to do, since we've already done the build, we want to be able to deploy the contract. You can also deploy the contract using the pop-cli command, which I just copied from here. The pop-cli command, sorry, adds, we're not expecting any argument, right? So we just don't pass any argument. So if you read through this command, and sorry, let me do something. So pop contract, you can see, sorry, what was that? Pop up, sorry, pop up. You can see it's either you pass a parachain or a contract. The good thing about pop-cli is it's going to give you a helper documentation whenever you press anything. So pop up contract, and then you press enter again. Sorry, this is just going to try and deploy it. So you can actually do that by pressing help. So it gives you a list of everything that is needed to be able to run the command. So it takes a constructor. These are the options: the constructor, the arguments, if there's any arguments, the value. So transferring an initial balance to the contract. If you want to transfer some funds to the contract at instantiation, you can pass a value. The gas amount and all of that, you can pass the SURI, which is a secret key for the account that is deploying the contract. So the account deploying the contract, you can pass a private key, or you can just use some of the dev ones, which is Alice, there's Bob, there's George. I mean, there's no George, sorry, but there's Charlie. So Charlie is there. And you can also perform a dry run. A dry run is what we are actually going to do, because it's going to first give us an estimate of gas that we're going to be needing to deploy this contract. So let's go ahead and perform the dry run first of all. This is just to give us an idea of how much we need to be able to deploy this contract. So it's saying localhost, which is a contract node. So we need a local node in the background for testing, because when you try to deploy your smart contract, you actually need to deploy it somewhere. So that's why the local node is needed. But as you can see, before it actually gets deployed, it also outputs the same things that's outputted from the build command. So just make sure that you've updated it, just in case you haven't built before. It just runs the build again. Even if it exists, it's still going to run it, just to make sure that nothing has changed. So now we're going to ask it to start the local node. So it does that. So let's start the pop local node, deploy a smart contract, and you can see it just gives us an estimate of the gas that's needed to be able to deploy the contract. So if you actually want to go ahead and deploy, you can remove dry run and just deploy the contract. So now the contract is deployed on this address. But one cool thing that I actually like to use to actually interact with my smart contract, because this guy actually allows you to interact with the smart contract as well. But you can see there's a lot of commands, CLI. It's very advisable to be familiar with terminals and commands and all of that when you are dealing with software with smart contracts and blockchains. But one thing that we're going to be using that I want to introduce you guys to is the Substrate Contract UI. This UI is a very cool tool that allows you to interact with your smart contract, deploy the smart contract, and all of that. It says could not connect to Rococo. Okay, we're not going to be using Rococo then. We're going to be looking for one of these test networks. I will pop network testnet. Yeah, pop network testnet. You need to have some tokens to be able to deploy, right? Obviously. But let me connect this. So as you can see, you can upload a new contract. You can use any address. This is similar to the private key, SURI. So you see that it takes the same parameters. The contract name, let's just call it Inc. Let's call it Inc. DNS. Then upload the contract bundle. So this is the cool part. This is where we are going to be needing those things that were generated while we were doing pop build and all of that. So let's just go to Inc. DSN demo, Inc. DNS, and then the target folder. This is where you find it. The Inc. folder. This is where you find it, and then you can upload this WebAssembly module. Just make sure you pick. You either need to pick between this WASM module or the contract module. Any one of them should do. Okay, it's not in a valid format. You see, it tells us the format is not valid. So if I pick this contract, yeah, this is actually the valid format. So you don't need to worry too much because you're using the UI. It gives you all this. And then you can see it's actually reading the contract and giving us everything that's available. The constructor, the default. Unfortunately for us, we didn't put documentation. But if you actually add a documentation, this is actually one cool thing that contract on Substrate does. But the way to add documentation is just to add comments. If you just add comments here, then get owner of the name. If you do this and then you try to deploy it again, you build and try to deploy, it's going to actually include whatever you provided as a comment as a documentation. So you don't have to worry about writing the code, documenting it again, and all of that. All the documentation can happen while you're building. And this is actually a cool feature of Rust itself, because when you're building Rust, when you're writing Rust, all your comments, it actually gets compiled into a docs. So you can actually refer to that docs by running cargo docs in your terminal, and then it's going to open a new web page that's very similar to something like this page right here that shows all the documentation that you need. So next thing is we're going to go next. But you see, it says I don't have enough balance. Unfortunately, I'm broke. So one place where I think I should have some balance is on Shibuya. This is also another smart contract platform where you can deploy your tokens. But you can also get free tokens from faucets. Like I was using Pop Test Network. You can actually get free tokens from the Pop Test Network, which is hopefully I can find it. It's get tokens on Pop Network. Get tokens on Pop Network. So Pop Network uses the Polkadot Relay Chain's native token. Pasio is Polkadot testnet, blah 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 blah. But the whole idea is you can get Pop token. How do you get the token? You go to Pasio Force chain, whatever. I don't know why I didn't see Pasio over there though, but let's just copy this. Hopefully this is the right one, and then put it in.
You change the chain. Why not change the chain to Pop Network?
Why not change the name to Pop Network, right? Yeah, because yeah, let's try that actually. That's a good idea. I don't know what motorcycles look like in this. I hate this game actually. It's a fun game, but if you are pressed for time, it's not that fun. Traffic lights. I don't know. Do I need to select everything for this traffic lights? I usually just guess, bro.
Okay, Pop Network is not there.
Yeah, you can see there's no Pop testnet right here. But funny enough, the Pasio testnet, I think there's actually like a discrepancy here, because the Pasio testnet is actually the testnet that the Pop network is supposed to be deployed on. So it's actually supposed to be the one that the Pop testnet uses. But let's try it out.
So you know what? I did something. Because I used this recently. So what will happen is when you get the pass, okay, you then bridge it into Pop. I think that's what I did. Let me get the bridge.
Okay. Good suggestion, right? So let's get the Pasio token. Usually, honestly, I usually use Asta Shibuya, so I'm pretty sure I still have a bunch of tokens on here, hopefully, or maybe I've used them up. So I have some past tokens in my Force right now. Let's see. Just like Femi just explained, if you get the Pasio testnet token, then you can try to bridge it and then use it. But I don't think we have 100% that much time to be able to go through all of that. But the whole idea is testnet to get Polkadot testnet token. This is actually a simple guide that you can follow to get the Polkadot testnet token. So let me paste it here for you guys. Yep. And this is somebody that just shared a very good guide on how to get this. Thank you very much. It's going to be a very interesting guide for us. You can get this. You can actually follow this guide actually to get the Pasio to PEP network. So you can follow it like this, onboard, blah, blah, and then you put in your token. It's going to bridge it for you. It's a very good guide. This same guide that we were on is actually what we use for that as well. So very effective. Select, sorry. Let me do it here so you can see what's going on. Let's do it here so you can see what's going on. Connect one account. Let's ignore this guy. Select some available address. Okay. Amount to send. Let's see. I wonder how much I have done. Let's see one. Let's see how this works. So this is actually a good way. So you can see successful, and we should be able to have some tokens now on the pop test network. So demo, let's try to deploy it again, DNS, and then, yep, next. Still doesn't have enough. Oh, interesting. I wonder how much token I got actually. Let me try to send 10. Should actually have enough token in my wallet, but because I'm using Firefox, should have a lot of tokens on my. Let's go back and make sure we're selecting the right address, which is FH. Okay. Should be the right one. I think I'm connected to this talisman wallet right here instead of the right address, and that is why it's not working. So now I'm connected to the right one in DNS. So let's get the contract. Hopefully I should have enough token. Yeah. So it tells you. So one good thing about this, you can see without even running the call or anything, you can tell if it's going to be successful or not. So this is going to be successful. So we just go next. We have all these things, upload and instantiate. I need to let you remember me for the next 15 minutes so I can actually work. So now it's actually instantiated. It says name already registered. Okay. Let's see the name. I think we might have a little bit of an error in the smart contract itself. Let's see. Expecting 64 characters. More storage was created and allowed by the storage deposit limit. Storage deposit limit exhausted. This could be because we don't have enough tokens here because we're currently holding exchange contract from InkDNS and farm knows a value of 0 passil. So it says more storage was created and allowed by the storage deposit limit. Interesting. No, let's add a new contract. Got this before. Let's just be sure. Let me use the JSON. Yeah, next. Oh, okay. This is actually the correct one. But it doesn't work because it says the name already registered. But let's try to get owner and see if this one works. Yeah, because if I return this, it's actually returning an actual value. So the address already has a particular hash. This guy. Based on the initial ones that have been deposited, the 0 address, I think this is the equivalent of the 0 address that we use to instantiate the smart contract. And then we can also do the caller is not the owner. This register is not working because the name is already registered. Contract call will be successful. Okay, I think it's not working because of the type of hash that we passed, because this is a very large value, I guess. Let's try it again. Oh, so what was that before then? Should be working. So yeah, you can see contract call will be successful. You can tell that it's going to be successful before you've actually called it. I don't know. What was that earlier? It's having a glitch or something. I'm not entirely sure. But yeah, it could be because of the hash that is passed. So it's probably not a supported value. So one cool thing that you might actually want to do with this smart contract is to pass, instead of passing a hash, one thing that I actually use in this particular scenario is to pass a vec U8. which is actually similar to, it's going to allow you to pass a string. So because the vector itself is actually a representation of a string. So you can actually pass something like this. And then in here, you'll be able to pass something like your name or something, which is the right thing that we actually need. So let's try this again. Contract call will be successful. Let's try to call the contract then to see that it's actually successful. I'm going to copy this name just so I don't lose track of it. So yeah, it's saying contract reverted now because this is already successful and the name has already been registered. So how you can know that it's actually successful if you try to get the owner, yeah, so paste this in. Yeah, you get this return value. Why does it keep on returning this guy though? Let me see. Yeah, the return value keeps on being this guy right here. That's so weird. Another good thing about this, even if you refresh, you can always still get access to whatever you've done. So nothing gets deleted. So let's just try and see, get owner. It returns the return value for this guy. Let me see. It's very possible that there's kind of like a little bit of an issue with this. Self.name.owner.gets the name. It should return the address. So let's see. Null. So this is actually not in existence, but this guy is not in existence. Yeah, he's returning now. So why wasn't it returning before? Maybe it was just taking a little bit of time, but you can see now it returns the address of whoever called this smart contract. So the address of the owner. You might be wondering why it's a little bit different from what is here, but because of it, it's actually happens because of the test and the chain itself. So that could be why this address is not always the exact same thing, but because the substrate addresses, there could be like different address variation for a single address. So you have one single address, but depending on the chain where the response is coming from, it might actually start with different things. So you see substrate addresses like Polkadot's relay chain address, they start with a 5, just the way it's starting right here. But if you check it, if you try to derive a new account, sorry, you see how this is actually 5HH and it's the same address that is actually, if you check it here, it's not the same thing. This one ends with CFD5W. Okay, the same thing actually. But in most cases, the substrate addresses might not be entirely the same thing. So right here is showing it as a substrate address, but in this place, it's probably showing it as a passive testnet address, which is what you see this one showing here, a pop test network address. So which is what you see this one showing. It starts with 16, and this one also starts with 16. So this shows that this address is working. I mean, this contract is working. So this substrate contract UI is actually a very good tool to be able to test your substrate contract without the hassles and stress of going through a UI, a terminal and all of that. So I think with this particular section, we probably come to the end of this one. So if anybody has any questions, I'm taking some questions at this point as well. If you have some questions, to just let me know, just fire on. Anything that feels confusing or not very clear. And yeah, for sure, I'm still going to be sending this documentation. Although all this documentation that I used, they're nothing new. The only one that I would say is new is probably something like getting this particular testnet, which Femi has kindly shared to us already. So thank you very much, Femi, for being so involved in the event and actually sharing this event. Really appreciate your presence. So a lot of these documentation have already been shared. The session is it being recorded? Adewumi, actually, I think you started the recording. Just verify if it's actually still continuing. It's being recorded. We're going to share the session on YouTube, maybe right after the call or a couple hours after the call. So yeah, thank you very much for coming, guys.
Yeah. Thank you very much, Balaji. Thank you. We really appreciate you.